Ray Lanier, and he's going to talk in a little bit more detail about the ability to see back through the splitter-based network.
Thank you, Jim. Again, I'm Ray Lanier. I'm with InLight Telecom, and we're again located in Washington, D.C. area. My subject is going to be on mechanized fiber test system, and that's basically a system specifically for pond testing, and to find a fault in the F1, F2, and drop, including the splitters themselves. So some of the challenges that, in talking to many of the providers of pond-based FTTH, FTTP type of systems, is the generally gain network visibility. You know, what does the plant look like? What is it doing? What is it today? Even from an inventory point of view, and more specifically, is to streamline the fiber installation process. And I'll go through that in more detail. But today, the outside plant technician is basically on his own to do that installation, and there's some challenges that they have in that process, and we'll get into that in more detail. Meantime to dispatch, this is especially on the larger carrier base, a big problem is because it's very hard in the tools that they have for fiber breaks and fiber problems such as connectors that get contaminated in microbands, and to minimize doing the wrong dispatch of the wrong work group, they spend more time to dispatch technicians, especially if it's beyond the splitter. The F1 typically is an easier one to say, oh, I know who to send out there. Might not know exactly where it is, but I know what work group to send out. So meantime to dispatch is a big issue. And then meantime to repair, because what you're really doing today in the present method of operation is you're sending out somebody to do sectionalization. And to do sectionalization, once you're out there to do fault location, we talk to current providers that send out simultaneously through 3 work groups to reduce MTDR. If the problem's beyond the splitter, and depending on how your workforce is divided, to send out a CO person, an INR, and a cable repair. And so 2 guys go home once they figure out what section it is, repair. And that's just to get main time to repair done. Of course, the cost is high, but that's exactly happening today. This is not theoretical. This is what happens today. Eliminate hygiene and handling issues is a major problem with I&M. Technicians who have been used to this wonderful, dirty copper world you could do anything in. We've been on visits where even, we'll say, knowledgeable people, construction side, doing OTDRs, and testing cable, never cleaning a connector, just going one, boom, 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 boom. And you know what that can occur. Well, it's even getting worse in the outside plant as deployment gets more in-depth. Limited access to inside fibers. People, especially MDUs, usually in larger municipalities, but also going to desktop ONTs. This is Verizon, matter of fact, is going to go to desktop ONTs for their MDU deployment. In Europe, especially in Denmark, for example, desktop ONTs have great value. Think of it. They don't have to be hardened from a temperature point of view. They can sit anywhere. They don't look intrusive. And they're just like a modem. That's basically it. They're less expensive. You can use a typical up supply to power. You don't have to get into anything very sophisticated as such. So that indeed is a movement to bring fiber right to the desktop, if you will. And now how do you test and verify that the inside fiber is good? And making appointments, we know what that is, especially for the service providers. And then ensure quality of service between proactive. How do I get to see a problem before it becomes a major problem? Microbands would be a typical one, or contamination. Say an area gets flooded where a pedestal is, and that pedestal gets flooded and they get contaminated. How can you find that problem? It might not be causing an outage, but it will tend to cause an outage later on. And so therefore, that is becoming a more, how do I get proactive as such, to keep customer satisfaction up. And then continually monitoring the system for, like I say, aging of plants. I mean, they say fiber never ages, but there's been studies that it does in some conditions, especially connector points and stuff and splicing points. So those are some of the challenges. I'll tell you, there's a lot more than that. So I'm going to go over some applications that relate to these issues, get into what fiber test systems look like from a deployment point of view, and then into the service activations, the installation process, and the service assurance or the maintenance process. Everybody should be familiar with this kind of diagram. The typical deployment of a PON system. In this case, I'm showing RF video because some people, Verizon, for example, but there are other providers that provide it that way, or you use IP video or a combination of both. But your plant looks pretty much the same as such. Nothing unique there. Some people use multiple splitters. In a PON deployment, you can actually use up to 3. I haven't run into anybody doing that, but it is not untypical in Europe to use a cascade of 2 splitters. You know, an 8x8 followed by 8x8s, for example. Or in Verizon right now is thinking of, in their GPON, they're doing a 1x2 followed by 2 1x32s in the field. So there are applications where you do get into multiple splitters, and the big issue is, how do I find a problem between those splitters? As a matter of fact, that was Verizon's initial reason not to deploy multiple splitters. It says, how can we really do that? How can I get an OTR look through that? Even more, how can I train a technician to figure out there's a problem when he looks at the OTDR? So that's another issue that occurs. But that's starting to occur even in Verizon, where they're putting a 1x2 in the central office as such. So in a remote fiber test system for PON, not much different from what Troy was talking about. We go into a WDM. Either we share a WDM where you have RF or you put one in for testing, because, again, we're going to be using a wavelength that's non-intrusive in this case. We have an OTR with extreme dynamic range. We're not going far distance, but we got a lot of loss in a sense. The splitter 1x32 represents at least 17 dB of loss. You can talk about 20, 21 dB for a 1x64. So we're seeing loss that would be equivalent to a very long cable. So dynamic range is important. The CPU, we're a software-based applications company, and that's our intellectual property, if you will, or anybody that's making a remote fiber test system. We use a test wavelength, 1625. Could be 1650 in some cases, but 1625 is more typical. And we shoot the fiber, and then we can detect which fiber branch on the F2 side is in trouble. That's the uniqueness of this type of system. The issue isn't saying, oh, I got a fault in the F2, but I don't know of one of 64 or one of 32 fiber. The real issue is, can you tell me which fiber is broken as such and where? It's a lot of black magic, it sounds like. Huh? So that's our base for using a 1x(n) operation. Same thing can be done in a 1x32. We still, in our application, recommend using the WDM coupler because, again, you don't want to have affect customers, obviously, in service. And if you have one out, that doesn't mean the other 31 or 63 are still operational. You don't want to cut their service off, especially if they're watching Dancing with the Stars or whatever it might be. So you want to minimize that experience that anything like that's going on. But in the N by M environment, not only do you have test access, but you have a LGX, a remote LGX that you can control, configure. There's a lot of issues about redundancy people were asking, but also provisioning as such, grooming. There's a lot of issues that you can do in an N by M environment, including the use of doing some testing, which is allows, we'll say, a return on investment that covers many areas. Okay, so service activation. Today, like I say, technicians are basically on their own. And part of this service activation is kind of required with our system. Much like Troy was saying, we need a database to compare with to say what has changed. I mean, we need that. We can use cable records, but the accuracy of the cable records we would import leaves to some questions, and you have to do some cleaning up as you go up to get the system tuned so you're more accurate on your dispatching. So ideally, we're starting fresh here. And then here we're showing where there's no customer connected. So you send out a technician, verify, what does the plant look like, including the F1. If that looks okay, and this can be done by the technician remotely using IVR technology if you want to utilize that, or by the NOC themselves. Then once that's verified, we got a good picture, we know where we are, we add that particular fiber and the F2. And what's good about this point, and this has happened a lot, is before that technician leaves to the FTT, he knows he's got a good fiber. In other words, the fiber's good up to that connection where that FTT is going to be. In this case, he's going to install an FTT as such because it's the first one at that location. And because normally what happens, say that fiber was bad, he would run out, check for lights. Gee, I can't see light. Run back and forth and stuff like that. And that can be, I usually deal with kilometers, so excuse me. But 2 kilometers, 4 kilometers, typically in an F2 type environment for FTTH. Or what if you connected one but it went somewhere else? We check that. So, okay, that distance looks right. Okay, he's good. Fiber's good. Go to the FTT, put that in, put in your drop. Go ahead, request a test. Test is requested. Test is done. It says you're good to go, and everything's fine, and you can go home or to your next job. So that's basically. Now we have a record of what that looks like, and we're putting an onion together because our technology as such it basically peels the onion apart. So we got to know what the onion looked like when it was put together. So on the second one, same thing occurs. We're testing. It said, okay, it looks like it was before. Nothing has changed. We're good to go. We can go ahead and add that F2 in, do that check, and verify it's going to the right place, and it has no problems with it. And then from that, install the drop, and then verify and good to go, and now we have that. So we keep doing this as time goes on, and a lot's what's happening now. Initially people were splicing their splitters in the cabinet, and now pretty well everybody's doing connectorization. So if a new splitter had to come into, the whole process begins. So it says that cabinet or that particular cabinet with those splitters is full. I put in my next splitter. He would go ahead and verify that the F1 is good and go through the whole process of building the onion, as I call it. So that's on the assurance side. I mean, on the installation side. So on the maintenance side, this is where things get pretty interesting, I would say. We can, using a remote fiber test system for PON, we can do proactive testing. And I know in the telephone industry, it's almost, some people consider proactive an oxymoron. What's proactive? But in reality, like ALIT you were mentioning and stuff, that doesn't exist other than these systems for the fiber network. And they're very beneficial. I mean, you don't have obviously the same issues in the copper world. Copper world, you got corrosion issues, you got, it goes on and on where you don't have the fiber issue. But there are issues that occur. But so we have proactive, then we can see what's going on. Microbands, again, because we're using 1625, it's more sensitive, so we'll see a microband that affects us before it might even affect the working wavelengths as such. And our system should be able to work with OLT EMS alarm system. In other words, an alarm occurs, there's no reason that can't be fed to a remote test system that says, go do a test on that particular fiber, for that customer. And then verify trouble not found or trouble found. That's what you want to do. If it says trouble not found, hey, my network, fiber-based, physical network, is okay. I got to look elsewhere for that problem. And then, of course, once you do have an issue, you want to have demand testing to do various aspects of looking for loss, and you want to dispatch to fault. And as I explained before, at least in a larger operation, we are doing multiple work group dispatches. And it gets worse because you have to train your I&M force to be able to use an OTDR, never mind having to purchase an OTDR. And again, if you're using multiple splitters, how does he see through that? I mean, if you look at a trace of a PON network with 32 connections at the splitter, you just see a single line, and you might see a little bump because it's kind of interesting. A 3 dB fault beyond a splitter on a 1x32 looks like 0.05 dB. And that's what our technology or technologies like ours are looking to resolve and tell you which fiber is in trouble. So, and then the other issue, which Troy brought up, which was music to my ears in the sense of that it's common, and we've heard it, is you send somebody in to start taking connectors, either in the CO to start troubleshooting. At that point, he can lose 32, 64, or 128 customers, depending on the PON configuration you have. He can go out to the hub and pull the wrong customer off and contaminate it, not clean it, which is the big fault. And if you've seen some cases, I mean, if you have a good workforce and a very methodical, and usually in small independents, because I've worked with small independents as well, usually you don't have that issue. But if you get where you start routing in a hub or a terminal, nobody can figure out what fiber is twisted among any fiber. So we get away from that kind of thing in a remote test system. And basically, the technician should be able to verify his work as such. And the system like this does say, go ahead, after you're done, did I make the correction? Is it workable? And so then I can go home, so to speak. So the issue here is getting the right work group. Again, and we could have communications through the EMS going in a common OS which says, hey, I want to do a physical layer test to verify what's going on. Or you can have directly demand testing going on. So what you have is, say you have a fault in the F1. And this is kind of interesting, Oh, that's easy, Okay, it's a break. It's easy. You got 32 customers. I know it's the F1. I can send somebody to CO and find a problem. What if it's a microband? And that microband's only affecting the 4 customers that are furthest out on that splitter. I got 4 customers out, but I got all my other customers working. Where would you send your work group? Would you send them to the F1? Probably not, because the problem is telling you it's in the F2. I mean, it's telling you because you might have a bundled F2 going to those customers. So, okay, that's where they are. And these do happen. What if it's the splitter that's bad? You say, splitters don't go bad. I tell you, I got customers who will tell you splitters go bad. 32 customers go out, And the system should be able to differentiate whether it's in that F1 or that F2 or that splitter. It doesn't happen often. I don't want to scare people, but I'm saying the issue with fiber compared to copper is, yes, it doesn't fail as much. It's got a lot of resilience. However, to fix it takes a lot of time and takes a lot of expertise. Nobody's going to question that, I'm sure. So, in this case, I'm showing it as in the F1, easy one for us to find, obviously, because it's, there's one fiber, boom. We say, hey, we have to dispatch a work group. Go ahead and repair that. Either the knock-in test or the technician in the field that did the repair do it, and verify that indeed light gets all the way to those customers and everybody's happy, and our technician can go on to his next job to do his repair, and we're good. So that's what we want to happen, and minimize any handling of fiber. Nobody touched a connector in that particular case. You're going to say, well, will there be times that somebody will? This isn't 100%, but it is in the 95 to 98% area of accuracy. If it's the F2, problems get a little bit more difficult because depending on how you, again, dispatch your workforce, are you going to, is it in a drop or is it in the cable? And in most companies, what happens, well, that's a different group. So in this case, we're showing it's in the F2, which is a cable repair group, not an I&M group that goes out. So we dispatch directly the cable repair folks to go ahead and make that repair. And therefore not have to worry about is it cable repair or is it I&M? Again, that's a workforce distinction, if you will. And if it's in the drop, then we have an issue of it looks much like an F2, the one previous. What's the difference? Again, the difference is we have a drop, and if we do have an I&M workforce only dealing with that, then that's where we want to dispatch, and that's the group we want to dispatch to make that repair and verify the repair is good once he leaves. So that is indeed a big differentiation of what's occurring. I'll also say, though, there could be F2 problems that are more identical that you can verify F2. If you had an F2 that was carrying multiple, obviously, customers, you would see multiple F2 failures at the same spot. And therefore, you say, well, that's F2. I can send somebody to that location or to figure out where the problem is. But in the case of a single repair, the two problems look the same. The other would be like an ONT fails and you had no warning. Well, you want to verify is my cable good? And this is no trouble found. Okay, and that's as valuable as trouble found because you say I don't have to look there. I'm good to go all the way to L&T. I'm going to send my I&M technician out, repair, fix. Maybe it's the power supply, whatever went, and he replaces whatever needs to replace. And then we still can verify the fiber's still good once he connects it up as such. Okay, so those are the various, there's multiple situations, but that kind of gives you the idea of some of the things. There's issues with even the CO. We could have an issue if you have a large central office and you have intra-building cabling. We've found a lot of people having problems with that at their patch panels and stuff. So we can detect, obviously, anything beyond where our access point is. If it's from an access point back to we can't tell, but even that says, if we say we got 32 customers out and we're good to go all the way out, then the presumption the problem is in the CO. So by default, there is a way of saying I have a problem inside. So the financial benefits, that's really what it's about, and it's the idea of reducing MTDD and MTDR. Dispatch to fault, fewer truck rolls, no simultaneous ones, or ones in parallel, which really drags out the process. Minimizing fiber handling. big issue. Again, I am amazed of how fiber hygiene is not adhered to the level. I mean, if anything goes in your deployment, you need to train your workforce as much to handle fiber. Really, the whole idea of cleaning fiber religiously, if I would say. Monitoring, reduce trouble reporting, because we find troubles before they're reported. We have a better database recording. There's even capacity, kind of a capacity planning capability where, because we know what's connected or not connected every time we do a fiber run or fiber OTDR trace, we can kind of feed that back to a capacity planning type of OS system where you could verify on my records, how many connections do I have on that PON? Was there any removals? I can verify that, and that didn't get recorded somehow. And then we can obviously get better early revenue because of quicker deployment and higher levels of customer satisfaction, reduced churn. That's what we want to deal, because it costs a lot, as you know, to deploy fiber to home. You do not want to lose customers. Questions? Question has to do, can I elaborate on our intellectual property? Okay, so you know the answer. The answer is, if you want to view it, you're invited to our lab facilities in German, Maryland, and to get into real details, sign an NDA, which we have NDAs to a lot of people, Verizon, France Telecom, British Telecom, and we'd be more than happy to get in detail. The issue, it does work. We can show you it works. So I know people say this is black magic. Yes, it is, but it isn't. It does work. The question is, do we have to retake our reference point once there's a repair done? There's a change. The obvious answer, yes, but we don't have to do it all 32. We don't have to disconnect everybody and redo it and re-put the onion, because we know how the other parts were put together in our algorithms, and then we take the overall picture, and that's what was contributed by the last repair. Okay, we do save the previous one, by the way, previous picture, if you will. Okay, go ahead.
Ray, what was IVR in that last slide that you had? What was the term IVR stand for?
Interactive voice response. IVR is interactive voice response. You have somebody with a cell phone, dial the number and code in a digit to do a test, password and all that good stuff. It's been done with remote copper test systems or T1 test systems. It's not new, but that's how you would do it, which really, though, now the technician does not have to wait on his hands for the knock to service him when he needs that test to be done. That's the whole idea. It really shrinks the amount of time.
It's been around the copper world for about 25 years. It's been around the copper world for about 25 years. They used to call it SALT system as well.
Yeah. This is in the Bell world. MLT does this, for example. Okay, thank you.